Hi, Doug Batten here for another step-by-step tutorial in grade 12 calculus. Today we're going to be working with optimization based on lowering a fuel cost, finding a lowest fuel cost. Let's get started.
Alright guys, today we're going to be working in our textbooks, page 202, question number 15. Let's get started. The cost of fuel per kilometer for a truck traveling v kilometers per hour is given. So the equation that's given is C, which is the cost of value v, which is kilometers per hour. V over 100 plus 25 over v is the original equation. The first question asks, what speed will result in the lowest fuel cost per kilometer? So we're going to focus on speed, which is going to be in kilometers per hour, and cost, because that's what we want to optimize for the lowest value. We take our equation, our original equation, and we're just going to work with a fraction in front of the variables, and I'm going to switch this to a -1 so that we can optimize this by differentiating it. So then the first step is to differentiate the equation, and then we're going to set the differentiated equation equal to 0. If it's equal to 0, that's going to give us a minimum or a maximum. In this case, it's going to give us a minimum cost. So we're going to solve this equation by bringing this this section over to the other side, 25 over v squared. Cross multiply, so it's v squared equals 2500. V equals 50 kilometers per hour. So 50 kilometers per hour is the speed at which will give you the lowest fuel cost per kilometer. Question B. Assume the driver is paid $40 an hour. What speed would give the lowest cost, including fuel and wages, for a 1,000 kilometer trip? So now the additional information they've given us is the $40 an hour payment that the driver is going to receive and the distance of our trip. So what we can do with this distance here is use our DVT triangle, which is distance equals velocity times time. Rearrange this into setting it equal for time. So time is equal to distance over velocity. Distance is 1,000. And what we have to do with this time equation is we're going to multiply it by $40 an hour, because since this represents our time, we need 40 times that per hour, $40 per hour. That's where we use this. And that's going to give us 40,000 over V. What this equation is representing is the cost of the driver. So what we're going to do is go ahead and add this to our old cost equation, but what we have to do to the old cost equation is also as well multiply it by 1,000, because multiplying it by 1,000 represents the 1,000 kilometer trip. Given our old equation, it was only the original cost per kilometer, so we now know our distance, so we can multiply that by our cost. And we have to add this new equation we found up here, the cost of the driver, cost of paying the driver. We have to add that in as well because it said including wages. And what we're going to do now is expand the 1,000 into the brackets, and I'm going to simplify down and combine like terms. So we're done here, simplifying, bringing like terms, setting it up once again, setting up the equation for chain rule because we need to optimize this. We want to find the lowest cost, and when the lowest at the time that the lowest cost occurs is when the differentiated equation, the first derivative, is equal to 0, and that's going to give us when the slope is equal to 0 on our cost and speed graph here. Right here is where the differentiated equation, derived equation, is going to be equal to 0. The slope is going to be 0, so it's going to give us the lowest cost. What we need to do is differentiate this equation using the chain rule, set it equal to 0. So now we just basically solve this like any other equation, solving for v. Bring this to the other side, cross multiply here, and we're going to be left with 10v squared equals 65,000. Right here, solve it out for v. V is going to be equal to 80.6 kilometers an hour. So what that 80.6 is representing is the speed at which we'll achieve the lowest cost of fuel. This is including all things, the wages, the distance, and the cost of driving the car. So why this is important and why this is handy to know is because if you were given a shipment company, or if you were an employee at a shipment company, you want to know how to make your shipping trucks have the most cost-effective methods possible. So with the additional cost, or with the cost of driving the car, so fuel, and the additional driver, paying the driver, you need to, it would be different numbers, but you would set up a similar equation to this, including whatever your distance of trip was and whatever your driver gets paid, to find your lowest cost, the point at which is going to give you the lowest cost with all these factors included. And that'll help you save money, that'll help profits go up, that'll help basically your business be run better and more effectively, which is why this is important to know. And that is